5 secrets about pandas. Look, I'm a machine learning engineer by trade, and these are 5 things that I didn't know about for a very long time in pandas, even though I use it daily. Kind of embarrassing to some extent. But anyway, I want to save you from that embarrassment and show them to you today. Import pandas as PD, kind of clear. Import seaborn as SNS, simply to load our favorite dataset, which is the Titanic dataset, which is my favorite dataset, or the dataset that I grew up in. So what is a Titanic dataset? If we just hit here data frame, we see that the Titanic dataset is a classical machine learning dataset where you were trying to predict whether somebody survived 0 or 1 based on a set of columns or features that you have right here. That doesn't really matter today because we're really just about pandas. Now, my first tip, and I don't know how often you've seen a line like this one where you're saying, hey, here's my data frame, and I want all the columns that are smaller than some value and bigger than some other value. So basically here all the people that were in the normal working population. What you probably didn't know, and this really is something that I didn't know until recently, which is maybe a bit embarrassing. You can simply say dot between 18 and 65, and it's so much cleaner and easier to read. And of course you don't have to put these annoying brackets around everything, which I still don't know why Pandas has to do that. Anyway, tip number 2, and this is also one thing that I only kind of started to appreciate when I had to do more Pandas code and actually do it professionally, and a bit less when I was back in university. What we all know is you can sort your columns. You can sort them by 2 values. What does that mean? So we're first sorting by people that did not survive and were in a low class, or in a high class actually, the first class, and this is the third class, right? So we're going from 0, 1 to 1, 3. What most of you probably also know is that you can give it the argument ascending equals to false, which will reverse the sorting order as we see here. So we're going from 1, 3 to 0, 1 basically. Now comes the actual trick. And this is something that really made me, in the past a bit ashamed that I was so stupid and didn't know that this is something you do. So you'll maybe get a bit of a workaround if you want to do the following. So you want to sort first by people that did survive but were maybe in a high class. So you want to go from 1, 1 to 0, 3. And the way I used to do it in the past is you simply say, hey, how about I just create, an inverse of this P-class field. And how do you do that? You just simply say it's the inverse of that class. And of course that does work, and you'll now get from 1, 1 to 0, 3. But the annoying thing here is you will have to drop the column after that, and you'll have some duplicated column. And here comes the trick. You can actually also pass an array to the ascending argument. So you can say, hey, first ascending false and then ascending true, which gives us the same thing without having to create a redundant column. Great. Tip number 3, and that's a bit about these very helpful little pandas functions that you hopefully use a lot. The first one is info, which you probably know. So you can hit info and you get an overview of all the data types. You get how many of each you have, you get whether nullable and blah blah blah, and you get the memory usage, which is really helpful, I personally think. Now, what you probably also know is that there's a describe function. What does the describe function do? It gives you a lot of helpful aggregated statistics about all your numeric values. So we have survives, p-class and so on. You have the mean, the standard deviation, the minimum, and several percentiles, which are pre-configured for you. Now, what you maybe still know is that you can give it the include all argument, which then actually will include all the features and not just the numeric ones. Now, what you probably did not know, however, is you can also say, hey, number, I only want that's the default argument, only want the float arguments to be shown. What you can also do, you can also show the categorical variables, and now here it gets really useful because it's way cleaner than when you get these strange, standard deviation of categorical variables. It's a bit ill-defined usually. Now you can do the same thing for booleans, and you can do the same thing for float. Now And I think that's the nicest trick of them all. With describe, you can also give it a custom percentile function. So you can say, hey, I want the 0 percentile, I want the 20th, the 40th, the 50th, blah, blah, blah. And you get all these nice percentiles that you didn't get before. Maybe you're very interested in the 25th percentile. Maybe you're really interested in the 17th percentile. For some reason, you can actually do this with Pandas only without having to do strange calculations. Now, tip number 4, and I personally didn't know that. Before I was working very extensively with strings in Pandas. Before that I somehow did apply functions and I don't know, for loops and really ugly constructs that are not very efficient. But you can completely use regex in all your Pandas function, or especially in contains and extract. Now, what is regex? For those that don't know, regex is like basically a small programming language that is really just concerned with how to work around with strings. If you don't know it, definitely something you have to check out. Now, how can you use it in Pandas? You can, for example, say, hey, we have here this embark town. It has a lot of different I don't know, cities and towns and whatever, but we only want the ones that are town and Borg, or contain these two substring. This is now the regex notation for getting that, and you simply put here a logical OR between them. You say, hey, Pandas, give me this series, make the string function, so you have to put the dot string to get all these string functions exposed, and you can then only select the ones you're interested in. Now, this is a game changer, but tip number 5 really is a huge thing, and especially if you're still somewhere in your university career or in academia, this may be a bit of a life changer, because you will often have to, you know, send strange, I don't know, screenshots and copy paste of nice tables around. And what you can do in Pandas is we'll just do it with 3 columns to not overwhelm you. We'll take age, which is integer basically, sex, which is in this case male or female, which is just, you know, a string of the gender, and we have the fare, which is a dollar value. Now, what you want to do if you want to get something like this, and that is really cool. So what you can do is with this .style.format function, you can completely customize how your table will be displayed, which is extremely nice. Why is it so nice? I mean, years, it's an integer number. Why should Pandas always display it as a float? I don't know why it does it, but like this, we can actually say, hey, years. So this .0f basically just tells us that we don't want any, you know, commas like .2 or .0 as it was here, right? Now, the same thing you can do for fare, but usually currencies are denoted with 2 decimals after the dot, so why not actually do it instead of having 4 like here? And of course we can annotate it with dollar, because this is actually the currency we are talking about. Now, another really handy thing is you can give it these lambda functions, and we want to convert, for example, female into F and male into M, which is the, I guess, more standard or easier way to look at this sex thingy, instead of having 0 or 1 or whatever. You know, it's just a bit more human readable, I would argue. Of course, you can also format your NaN values, especially if you're talking to people that may not know about non-applicable nulls and whatever the hell you're working with. You can succinctly say, hey, I'm a missing value, or missing, or not applicable, or, you know, a minus, whatever you're feeling like. The last little trick here is with the background gradient, which actually gives you, and this is kind of helpful, I think, it gives you an overview of the distribution while you're looking at the table. So we know now that dark blue colors are high values, and we know now that you know, reddish colors are low values. And then we have the spread between those 2 values, which is here for the fare. We immediately know that this is a pretty high value and that this is a pretty low value, which may not always be directly obvious to viewers of your data. I mean, of course, to you, because you're working with the data, but not someone else. And this is the life-changing thing, I promised you. I don't know how often in my life I went to this strange website. If you don't know it, it's a LaTeX table creator. So to all of those that don't know LaTeX, that's okay. If you know it and you ever had to write any university papers, it can be a huge pain to put your tables into, you know, this strange form of writing here, right? So you go like this, and then it's so much code, right? What the really life-changing part now is you can actually do this directly from Pandas. So all you have to do is style, format to LaTeX, and you'll get this table here. This was it with me for the week, and I really hope you'll learn something life-changing today. Now, if you're looking for more, I can definitely recommend my video on feature scaling in machine learning, which is definitely something every Pandas data scientist has to know about. If you're looking for a bit more something practical, I can absolutely recommend my video on building a machine learning API using Fast API, which by the way is also a very common topic in machine learning interviews if you're ever trying to break into that field.